Welcome to this lesson on gas laws and isothermal processes. Today, we're going to solve a problem involving Boyle's law and see how we can use it to find the pressure of a gas after it undergoes an isothermal expansion. Let's look at our problem. The initial volume of a certain gas is 528 cubic centimeters at 45 kilopascals pressure. During an isothermal process, the volume of gas increased to 888 cubic centimeters. What is the pressure of the gas after the process? Let's identify what's given in the problem. We have the initial volume V1 equal to 528 cubic centimeters, the initial pressure P1 equal to 45 kilopascals, and the final volume V2 equal to 888 cubic centimeters. Most importantly, we're told this is an isothermal process, which means the temperature remains constant. Let's first understand what an isothermal process means. Isothermal means that the temperature remains constant throughout the process. In our case, the gas is expanding from a smaller volume to a larger volume, but its temperature stays the same. Let's visualize this at the molecular level. Here we have a container with gas molecules. During an isothermal expansion, the volume increases, but the temperature stays constant. As the volume increases, the gas molecules have more space to move around, resulting in fewer collisions with the walls of the container. These reduced collisions lead to lower pressure. For an isothermal process like this, we can apply Boyle's law. Boyle's law states that for a fixed amount of gas at constant temperature, the pressure and volume are inversely proportional to each other. Mathematically, this is expressed as P1 times V1 equals P2 times V2. We can also visualize this relationship on a pressure-volume graph. For an isothermal process, the relationship follows a hyperbola. As volume increases, pressure decreases, and vice versa. In our problem, we're moving from this initial state with volume V1 and pressure P1 to this final state with volume V2 and a pressure P2 that we need to find. Now, let's use Boyle's law to find the final pressure P2. We can rearrange Boyle's law to solve for P2. P2 equals P1 times V1 divided by V2. Let's substitute our known values. P2 equals 45 kilopascals times 528 cubic centimeters divided by 888 cubic centimeters. First, let's multiply 45 times 528, which gives us 23,760. Then, we divide by 888 to get approximately 26.76 kilopascals. Therefore, the pressure of the gas after the isothermal process is 26.76 kilopascals. Let's think about what this result means physically. Our gas expanded from 528 cubic centimeters to 888 cubic centimeters, which is an increase by a factor of about 1.68. Since pressure and volume are inversely proportional in an isothermal process, we would expect the pressure to decrease by the same factor. Let's verify. 45 kilopascals divided by 1.68 is approximately 26.76 kilopascals, which matches our calculated result. This principle has many practical applications, such as in scuba diving. As a diver descends deeper into water, the pressure increases, causing the volume of air in their lungs to decrease. Conversely, when ascending, the pressure decreases, causing the air to expand, which is why divers must exhale while ascending to prevent lung damage from the expanding air. Let's summarize what we've learned. In an isothermal process, the temperature remains constant. For such processes, Boyle's law tells us that pressure and volume are inversely proportional. Mathematically, P1V1 equals P2V2. In our problem, we had a gas with initial conditions of 528 cubic centimeters at 45 kilopascals. After an isothermal expansion to 888 cubic centimeters, the pressure decreased to 26.76 kilopascals. Understanding gas laws like Boyle's law helps us predict how gases will behave under different conditions, which is crucial in many fields from engineering to medicine. Thanks for watching, and I hope this explanation has been helpful.